Okay, quiz review. So perform each matrix operation. Right here is that you're adding, so you can add these two matrices because they're the exact same dimensions. So you just add their elements. So 6 plus -1 is 5. 5 plus 3 is 8. 8 plus 7 is 15. And then 7 plus 10 is 17. So those are your elements. B, you have a number next to it. This is called a scalar. So you're going to multiply everything through by the scalar on the inside. So this is going to be -40, 8, 12, 24, -20, and 28. And then letter C is you're multiplying a 2 by 2 matrix times a 2 by 2 matrix. So you can do that because the inside dimensions are the same. These two are the same. So the resultant is going to be a 2 by 2, matrix. So to multiply, you're going to multiply the first row by the first column. So you're going to multiply -2 times 2, which are these two first ones, plus the second part, which is 3 times 7. So -2 times 2 plus 3 times 7. The second element, you're going to multiply -2 times 3 times the second column. So it's going to be -2 times 8. Or I think I said 3, but -2 times 8 plus 3 times 6. I'm going to switch color. And the next element right here, you're going to multiply the second row by the first column. So it's going to be 5 times 2 plus 4 times 7. And then the last one, you're going to do the second row, second column. So it's going to be 5 times 8 plus 4 times 6. So now we're going to go through and simplify all of this. So I have a 2 by 2 matrix. So it's -4 plus 21, 17. -16 plus 18 is 2. 10 plus 28 is 38. And then 40 plus 24 is 64. There's your answer. Okay, and then letter D, you're multiplying 3 rows by 1 column times 1 row by 3 columns. So you can multiply these two because it's a 1 by 1. They're inside. So this is going to result in a 3 by 3. Kind of different. So it's going to be 2 times 8. It's your first one. And then 2 times -2. Then 2 times 3. Then it's going to be 6 times 8, 48. 6 times -2, -12. 6 times 3, 18. And then the last one's going to be 7 times 8, 56. Then 7 times 12, -14. 7 times 3, 21. So that's a 3 by 3. The resultant's going to be 3 by 3. And the last one is you have a 2 row by 3 column times a 2 row times 1 column. You can't multiply these because these are not the same. So nope, you can't do it. Or impossible. So down here, explain how to determine whether you can add or subtract matrices. They have to be the same dimensions, and you can give examples. And then number 3, explain how you can multiply them. So in order to multiply them, the inside dimensions have to be the same. So these two you cannot multiply because these two are not the same. But you could multiply these two matrices because the inside dimensions are the same. Okay, number 4, explain the transformation. This is the notation that we have for transformations. This is meaning that you're going right 5 and then down 2. Okay, number 5. Matt walks 8 blocks west. So west, you got north, south, east, west. So west is negative. So 8 blocks west, negative 2 blocks north. So plus 2 minus 8. And then he's going 3 blocks east. So that's going to be plus 3, and 1 block south, minus 1. Use translation notation to show where it adds up, where he ends up. So my first transformation is going to look like this. Don't forget your arrow key or arrow mark. Then it's going to be x minus 8, y plus 2. Oops. And then the green one is going to be the same transformation notation, but then I'm going to go x plus 3 and then y minus 1. So when you put these together, you're going to have the final transformation. Negative 8 and 3 is negative 5. Plus 2 minus 1 is plus 1. So there's my answer. And then 6, write if a is at 6, 5 and a prime is at negative 9. Describe the translation with proper notation. So if you are going from 6 to negative 9, you are going down, or you're going negative 15 in the x direction. And if you're going from 5 to 5, you're not moving, so you're just going to write y. Or you could write y plus 0 or y minus 0. Use matrices to show the preimage being translated 4 units up and 2 units to the left. So first, to use matrices, I'm going to write this as a matrix. So remember the x's go on the top and the y's go on the bottom. So if it's going to be translated 4 units up, that needs to correspond with my y. Put a plus sign. So my y is going 4 units up. So my y is going to be positive 4. And there's going to be 3 of them because there's 3 over here. And then 2 to the left means I'm going negative 2 in the x direction. So you're going to add these two matrices together, and your resultant, you're going to add the elements. So it's going to be negative 1, 0, 3, 10, 7, 11. Then you always want to write your answer as an ordered pair. So it's going to be E prime is negative 1, 10. F prime is 0, 7. And G prime is 3, 11. Okay, then reflect x is at negative 4, 5. So that is right here, x. Across the x-axis, here's the x-axis. So it's going to be down here, I write x prime. Reflect a, so a is at negative 2, 3. Across the y-axis, so this is the y-axis. It's going to go on the other side and be a prime. And then the last point, reflect G, which is at right here, across the line y equals 2. So I draw the line y equals 2. It's on the y-axis. Y equals 2. So G prime has to be right here. G prime. And then number 9, use the image of A, B that has been reflected across the line y equals x. So you have to use matrices. So I go to my matrix reflection sheet, and I need to write that first. So I'm going to write the matrix reflection for y equals x. So that is 0, 1, 1, 0. I need to write that first on the left-hand side. Then I'm going to write the ordered pair. Put your x on top, put your y on the bottom. So negative 6, 7, 4, 7. And now you're going to multiply the first row by the first column. So you do 0 times negative 6 plus 1 times 7. So it's 7. 0 times 4 plus 1 times 7 is 7. 1 times negative 6 plus 0 times 7 is negative 6. And the last one is 4. See, when you have y equals x, the x and the y just flip-flop. So this was on the bottom, now it goes to the top. So then at the end, don't forget to write your ordered pairs. A prime is 7, negative 6. And B prime is 4, 7, or 7, 4. And then number 10, the pre-image x, y, z. So I'm going to graph x, y, z. X, y, z, right here, triangle, has been translated x plus 4, y minus 3. So that means it's going right 4 and down 3. So each point I go right 4 and down 3. 1, 2, 3, 4, 1, 2, 3. So this is x prime. 1, 2, 3, 4, 1, 2, 3. This is y prime. 1, 2, 3, 4, 1, 2, 3. That's z prime. Make sure you're labeling your primes too. It should be the exact same shape, exact same size, because it's isometry. And then graph and do the same thing with x, y, z, y, z, except for this time it's going to be reflected across the x-axis. So this is my x-axis, so it's going to be down here. -5, -2 is x prime. -3, -4 is y prime. And then -1, -4 is z prime. Like that. So if I drew it nicely, or nicer, it would be, this triangle would be the exact same shape and the exact same size because it's an isometry.